Okay, here we are, 5.2. So we're looking at polynomial functions, and we have to start by defining some terms here, starting with terms. So a term is a number or the product of a number and variables raised to some power. So like this term is just a number, and these terms over here, like this guy and this guy, are the product of a number and some variables. In this case, just x or x to the fourth. So one thing is when we're talking about terms, the sign goes with them. So this expression has three terms, and those terms are 9x to the fourth, then negative 7x, and negative 1. So you can think about that, back to some of the first stuff we talked about. You could also think about this like 9x to the fourth plus negative 7x plus negative 1. But if we're talking about the terms, I'm going to use kind of this idea, but just sort of include that subtraction as meaning that term is negative. And so this is a big back and forth between our different concepts of what subtraction and negation are. Now this is just one term because all these things are being multiplied. So terms really are things that are separated by addition or subtraction. And this is just one term because all these things are being multiplied. So one thing that we'll talk about, and we've talked about this a little bit so far, is the coefficient of a term. And a coefficient is the number part of the term, is the number part of a term. So that means, for example, if I have this term from up there, 9x to the fourth, the coefficient of this term is 9. So just the number part. This has coefficient of 9. And if I have this term, 7xy cubed, that term has a coefficient of 7. Now, if a term only has one part, then it's just the number part. If a term is just a number part, then it's a constant. So for like here, this has a constant term. And then as we said above, this term has coefficient 9. And this middle term has a coefficient of negative 7. And that's because you can think about that subtraction as being the addition of an opposite. Okay, so now we're defining something called a polynomial. And a polynomial in x, so that means x is the variable, is the sum of a whole bunch of terms of this form. So some number, a coefficient a, times the variable x raised to some power. A is a real number, so a can be any real number. That means there's a lot of different things. It could be pi, it could be negative 10, all kinds of different things. But n, the power that the variable is being raised to, has to be a whole number. And remember what a whole number is like 0, 1, 2, 3, 4, 5, stuff like that. Those are the whole numbers. So a couple quick examples just of some polynomials, what these might look like. You'll see a lot that look like this, like 7x squared minus 15x plus some number, let's say a half. So here we have three terms. Each of them is a coefficient and then a variable or just a constant. And you can actually think about that constant as being multiplied by x to the power of 0. Because remember, anything to the power of 0 is equal to 1. We can also have some really, weirder looking polynomials. This is another thing that is a polynomial, like 2.7 times x to the power of 200 plus 4x squared. So, as long as what you really want is that these exponents are whole numbers. You don't want anything that is in the bottom of a fraction or in radicals. So these are really nice functions. Some polynomials have special names, and it's only 3 of them, really. So a monomial is a polynomial with one term. So for example, like a one-term polynomial would be like 14x to the 7th. Monomial, mono means one. So like if a teacher speaks in a monotone, it's using only one tone, and it's a pretty bad way to teach a class because it's very, very, very difficult to listen to. Binomial is a 2-term polynomial. So bi meaning 2, like a bicycle. It's a bummer that these are monomials and not uninomials, because then we could go bikes all the way up. But instead, binomial. So a binomial is a polynomial with 2 terms. So for example, a 2-term polynomial could be like 2.5 times x cubed plus 7. That's a single polynomial, but it has 2 separate terms. And then the last one we have a special name for is the trinomial, and that is a polynomial with 3 terms. We're going to look at a lot of these. So here, we'll see stuff like this. This is like that kind of thing. And they don't have to be, they can have different powers, but it's just what this is about is just that number of terms. So I have 1, 2, 3 terms. For polynomials with more terms than this, we don't have special names for them, so you don't have to worry about like quadrinomials and pentanomials. At that point, I would just say this is a 7-term polynomial. So we have one more concept here, and that is the degree. And to start out with, we're just going to talk about the degree of a single term. And so all the degree of a single term is the sum of the exponents on variables in that term. So, for example, this one, 3x squared, that is degree 2. Here, now I have my 2 is being raised to a power, but this is my only variable term. So this is degree 5. Over here, I've got x squared, y to the first, z cubed. So that is degree 6. Because 2 plus 1 plus 3 is 6. And then my last one here, this is degree 0, because it is a constant term. There's no variable in there, so the variable is not raised to any power, so that is degree 0. Now the last thing here is the degree of a polynomial. So there's just one thing that can be kind of confusing about this degree of a polynomial. Okay, the degree of the polynomial is the greatest degree of any term of that polynomial. And what people sometimes do is add up the the degrees, and you don't. You just look at the biggest one. So I look at these three terms. This term is degree 4. This middle term here is degree 1. And this last term is degree 0. So now this isn't hard. All I have to do is look at these three numbers and see which one is biggest. This is biggest, so the polynomial is degree 4. So it's not hard, you just have to remember to not add them up. And it's confusing because you add, to find the degree of a single term, you do add those exponents because that's multiplication, but to find the degree of a whole polynomial, you do not. This next one, these individual terms, this one is degree 1. This term here is degree 3. And degrees end up being a big deal because they're sort of a measure of how complicated a polynomial can be. So it's something that we don't get that into in this class, but if you keep going with algebra, then you will see a lot more of this when you're trying to graph a really complicated polynomial. If you figure out what degree it is, that can help give you some information about how crazy that graph can look. So the polynomial here is degree 3. Okay, next page. Okay, so here's the next page. We're done with that straight vocabulary stuff for now, and we're moving on to some more ideas about these functions. So this would be part of the question. You might recognize this function notation from chapter 8. We looked at some linear functions. The only difference now is there might be variables on those exponents. So as part of the question, you are being asked to find p of 1 and p of negative 2. And so for that first one, let's look at p of 1 over here. So I'm going to take my function, and I'm going to do this the same way I was doing it with that chapter 8 stuff. I'm going to rewrite my whole thing, and I'm just going to replace all of those x's with parentheses. And then remember, the thing that's inside of my parentheses in my function notation is the thing that I'm plugging in. So everywhere there was an x, I'm going to put that. And now I just go through and simplify all this. So I end up with p of 1. And remember that p of 1 stays like that. Like this isn't p times 1 or anything. So I have 3 times 1 squared is just 3 times 1 minus 2 minus 5. P of 1 equals 3 minus 2 minus 5. 3 minus 2 is 1. And eventually I get down to p of 1 equals negative 4. And so this would be my answer. The function p, evaluated at 1, gives me an output of negative 4. So let's take a look at this other one. P of negative 2. I'm going to do the same thing where I just take my function and rewrite it with parentheses replacing my variable. And now the thing that I am plugging into this is negative 2. So p of negative 2 is 3 times negative 2 squared. And now you know, especially from some of those exams, that this can get a little dangerous. So I'm going to be careful. I have 3 times negative 2 in parentheses squared is positive 4. Minus, so you can think about this as like plus negative 2 times negative 2. That might help. Either way, what you end up with is plus 4. And one way you can think about that is like I have an even number of little horizontal lines here, so that means it's going to end up being addition. Minus 5. Then I have p negative 2 equals 12 plus 4 minus 5. P of negative 2 equals 16 minus 5. P of negative 2 equals 11. So that would be my answer. Okay, and then we have a word problem here. Okay, so here we have a word problem, and now we've done a lot of pretty tough word problems, and some of those mixture problems, some of those ones where you really have to build an equation. Now this is a different type of word problem. This is a problem that in many ways is a lot easier, but it can really, people sometimes get really intimidated by it because it's a physics problem, and so people get a little freaked out that they're going to have to do physics. But here's the deal, and when you look at a problem like this right away, what should make you feel happy is this. They are giving me an equation, so that means I don't have to think about like how I'm going to build a big bookshelf, or like how many, what percent acid solution to mix with some other acid solution. They're going to give me a bunch of information, and this is important, but they're giving me the physics part. So I don't have to think about like building up a big complicated physics equation. They're telling me what it is. And it's interesting, and these equations are great. And if you want to go further into this stuff, any physics class will go through how to build these equations up, and it's honestly pretty great. But after looking at this and seeing that there was an equation in it, maybe chilling myself out a little bit, I can go through here and read this. The Swiss building in London is 590.1 feet tall. That seems like it's going to be important, so I'm just going to mark it up here. An object is dropped from the highest point of this building. Neglecting air resistance, the height in feet of an object above... Oh, this is a mess. Object above the ground, whatever. At time t seconds is given by the polynomial function this. Find the height t when t equals 1 and when t equals 6. So that would be given. You don't have to know what times to look for. So all they're saying is the height, this function is outputting the height. So this is height at time t. So all you have to do is take that function. So this is p of some time equals negative 16 times some time squared plus 592. And now the first time I'm looking at is when t equals 1. So when t equals 1, this is going to output for me the height. So p of 1 equals negative 16 times 1 squared is just 1 plus 592. Now I add those together, and I end up with p of 1 equals 576.1. And so what that means is they're talking about feet. So after 1 second, the object is 576.1 feet off the ground. Now they also are asking about t equals 6. So I would look at my same function. P of some input equals negative 16 times the square of that input plus 592. And what I would plug in there in this case is 6. So I'd put a 6 here, a 6 here. And now I just go through and simplify. Now that 6 squared is 36 plus 592. So I end up with P of 6 equals negative 16 times 36 is negative 576 plus 592. Whoops, I'm going to fix that. Plus 592. When I add those together, I get P of 6 equals 16.1. So this tells me that after 6 seconds, the object is 16.1 feet off the ground, or 16.1 feet above the ground. Okay, then we've got a group problem. I'll have you guys do that. What I'd like you to do is find what that P is at what that function evaluates to when x equals 1. So find P of 1 and find P of negative 4. And be careful, make sure that you are checking those negative numbers. And I'm just going to put the solutions here so you guys can check yourself. P of 1, this should end up being 4. And P of negative 4 ends up being negative 21. And if you are having trouble with those, talk to me, talk to Chrissy, talk to anyone at the Learning Center, come to the office, come to my office hours. We'll get it figured out. Okay, next page. Okay, one more thing in 5.2, and that is this big idea, polynomial-like terms. So we talked about like terms a little bit before. Two terms are like only if they have exactly the same variable part. They have exactly the same variable part, including powers. So here's a couple just really quick little examples. If I have 3x squared y plus 7x squared y, these are like terms. So these are like terms because both of them are counting up x squared y. That's the type of variable that they're looking at. I have 3x squared y's over here. I have 7x squared y's over here. When I add them together, I end up with 10x squared y. Whereas here, if I have like 4x plus 2x squared, these are not like terms. They look really similar, but they're not quite the same. Not like terms. And the reason they're not like terms is because even though the variable is the same, this x is squared and this one isn't. So the variables are raised to different powers. Okay, so here's a couple examples, adding like terms. So here, these things are just being added. These are two polynomials. I'm adding them together. So because addition is the only thing that's happening, I can just drop those parentheses. Because really all I'd be doing is distributing a positive 1, which doesn't change anything. And now what I want to do is look through here and try to identify as many like terms as I can. So here I have 7x cubed y. Do I have any other? Yeah. Here I have 6x cubed y. So I can take my 7x cubed y and my 6x cubed y, add those together, and I get 13x cubed y. Now I have an xy cubed. Looks like that's the only xy cubed I have, and it's being subtracted. So I do that. And now I've got, let's see, 11 plus 11 minus 4. If I add 11 and then subtract 4, that's the same as adding 7. So this would be my fully simplified polynomial with all of my like terms combined. I'll do one more example over here. I have 3a cubed minus b plus 2a minus 5 plus a plus b plus 5. So now I only have one a cubed term. So that's just going to come straight down because there's no terms that are like it that I can combine. Now if I subtract b and then add b, I end up with no b. So I'll write this down here. So minus b plus b. I add 2a and then add another a, so plus 2a plus a. And this is a good idea sometimes if you have one that is kind of tripping you up. A lot of times people get confused about things that equal 0, minus 5 plus 5. And it can help to kind of rewrite things like this. And then I can go, and I've got my terms right next to each other. I can see that that's going to be 0. These a's, I'm going to end up adding 3a. And then my 5s are going to cancel out as well. So this would be my final answer for that one. Okay, we'll take a look at a couple subtraction problems. Things get a little bit more complicated, but really nothing that's too different than what you've seen before. So here I've got these polynomials. I'm subtracting. We're going to use the same techniques we've used in the past to subtract two polynomials. Change the signs of the terms of the polynomial being subtracted. So this is the polynomial that's being subtracted. So just like we've been doing, in all these other problems, I need to be careful that that subtraction distributes to all three of these terms. So it's going to change the sign of the first term. Let me just get this first polynomial. Now nothing happens to this polynomial because it is not being subtracted. The subtraction is happening to this second polynomial. So minus 2x cubed. Then I'm subtracting the opposite of x squared. So I'm adding x squared, and then I'm subtracting 1. So that was positive 2x cubed. Now I'm subtracting it, and then these operations change. Now I'm just going to go through, after you get that distributed, it's the same. I'm just going to go through 2x cubed minus 2x cubed. I end up with 0x cubed. 8x squared plus x squared. I have 9x squared. Then I have minus 6x. That's my only x term. So I'm just going to write minus 6x. And then I only have one constant, and that's 1. So minus 1. And that 1 is being subtracted. So that's my final answer there. And this distribution of negatives ends up being one of the biggest things, definitely on that first exam. This is one of the main places people lost points. It can really help to draw these little arrows, but then sometimes people draw the arrows and then don't actually do the distribution. So make sure you do the whole thing. So I have 9a squared b squared plus 6ab minus 3ab squared minus 5b squared a minus 2ab minus, plus, I almost did it, plus 3. So that should be minus. This plus turned to a minus. This minus turned to a plus. And then this minus is going to turn to a plus. 9b squared. And I talk about this all the time, but it's not about trying to never make mistakes. It's about knowing how you make mistakes so that you can catch them. Because I promise you, sometime in this class, you'll make some silly math mistake. So you just have to know how to catch it. This, I believe, is my only a squared b squared term. So I end up with 9a squared b squared. Do I have any other ab's? 6ab, and then I'm subtracting 2ab, so that's 4ab. Let's see. Minus 3ab squared. Now, it doesn't look right away like I have any other terms common, but because multiplication can happen in any order, these are actually the same. They are like terms because minus 5b squared a is the same as minus 5ab squared, because that multiplication can happen in any order. And this is something you'll see as we keep going forward, especially into chapter 6. Sometimes like terms will kind of sneak around like that, and things that look like they're not like terms really are, things that look like they are actually aren't. So you have to definitely remember to stay on your toes. I only have one constant, and that's 3, and then I've got this 9b squared, and that is my only b squared. So I have that, and that is my fully simplified polynomial. Then I can go back and double check, like, are any of these like terms? No. Did I make any mistakes? Was I right about this? I was. Okay. So, as always, let me know if you have any questions.